All right, so now we're going to write the half reactions for redox reactions. So what we need to do first, like we've done before, is we're going to have to find the oxidation for all of them, for each element. So when we do that, we notice that this is a solid and this is going to be a gas. And so in order for this, magnesium, it's by itself. And so we're going to say the oxidation state is then 0 because it's magnesium solid or magnesium metal. Then we have oxygen. Oxygen is a diatomic, so the oxidation state is also 0. Then we have magnesium oxide. So this is when we have magnesium plus oxygen is equal to 0. So what's the oxidation numbers for each of these elements? So we don't know magnesium, so it's going to be based upon what oxygen is, which we know oxygen is -2 based upon that chart. And then magnesium would have to be +2. So we have +2. Oxygen is -2. So what is occurring is that we are going from, so for magnesium, it's going from 0 to +2. So we would say that this is being oxidized. Then we look at oxygen. It's going from 0 to -2. This is becoming less, so this is being reduced. Then in order to write half reactions, so we have to do with our oxidation. We'll put O for oxidation for a half reaction. And so what's happening is we have 2 magnesium, and this is solid. And then it becomes 2 magnesium, 2+, and we're losing 2 electrons because it went from 0 to +2. Now we're looking at reduction. Reduction is looking at the oxygen. So we have O2 gas. It's going to gain 2 electrons. So this is going to be on the left-hand side of the arrow sign to show the reaction. So it's going to be over on the reactant side. So then we have O2 gas plus 2 electrons is equal to 2O. And we have 2 negative. So this would be our half reactions for the following. Now let's just make sure we cover and we remember. So magnesium solid is our reducing agent because it itself is being oxidized. And then our O2 gas is our oxidizing agent because it's going to be reduced. Now, the problem didn't ask for this, but we know that these are the 2 things as we've covered them before. So it's just a review. Now let's do another example. Write the half reaction for the following. So we have aluminum metal plus oxygen gas is equal to aluminum oxide. So the first thing we're going to have to do is we're going to have to find the states, the oxidation states or oxidation numbers for each of the following. So we have aluminum solid. So this is just going to be 0. It's all by itself. So it has to go back to that rule 1. This is also 0. It's diatomic compound, and so that's 0. And then we have aluminum oxide. Notice that this is a neutral compound. So we know that we have 2 aluminums, and then we have 3 oxygen. And this has to equal 0. Okay, so notice that here we use the subscripts because we have 2 aluminums and 3 oxygens. And so this plays into the oxidation number. We do not account for this 2. So just remember, it's just looking at the compound. So as we go from this reaction, we need to find the oxidation states for these 2. So we know oxygen is going to be -2 based upon the chart and priority, and then we're going to have to figure out what aluminum is based upon oxygen. So we have 2 Als, or aluminum, and then we have, so let's rewrite this. We have plus -6 equals to 0, so then 2 Al is equal to 6, so Al is equal to +3. So this is +3. This is -2 for oxidation state. And so we can see when we look at aluminum, it's going from 0 to +3. So we would say that this is being oxidized. Then we look at oxygen, and this is going from 0 to -2. So we would say that this is being reduced. So now let's look at our half reactions, because we know what's being oxidized and what's being reduced. So when we deal with oxidation, we're looking at aluminum. So it's going from 0 to +3. So that means it's losing 3 electrons. So what we would have to do is we would write aluminum solid. Now we need to include the coefficient. So it's for aluminum solid, then we have the arrow, and then it becomes 4 aluminums, and then we have, looking at this, the oxidation state, it's 3 positive. Then we're looking at how many electrons did we lose? We lost 3 electrons because oxidation is lost. So we put, when we have the oxidation half reaction, the electrons is on the right-hand side. Now for reduction, we have oxygen. So we're looking at oxygen. It's being reduced. Now it's gaining 2 electrons because it's going from 0 to -2. So what we do is we're going to write 3O2. This is a gas. And then it's going to have to gain 2 electrons for every oxygen in order to become 6O2 negative. Notice that on the left-hand side, we're putting the 2 electrons for reduction, whereas in oxidation, it's on the right-hand side. Also, notice that we have 2 electrons here and 3 electrons here. For finding the total reaction, we would have to do some manipulation of these 2 reactions in order to balance them out, because we need to have a balance of electrons of what's being transferred. But we're just going to deal with half reactions. So we would keep our answer as is. And if you want to learn how to do the full, we might cover it on Wednesday for a brief few minutes.